How have you seen the nature of innovation change through your customer base in the last 10, 15 years?
So maybe I can start that off. One of the things we've really seen in the last period of time is really a drive for this convergence of different technologies. And as the drive for smarter systems continues, the need for engineers to be able to handle multiple disciplines, to be able to do much more than the particular discipline maybe they went to school for, is really increased over time. And I think a great example of that, which links in with the drive for innovation, is the Chevy Volt itself, because that vehicle represents bringing together multiple types of technologies and pushing engineers in places they haven't been pushed before. And so if you look at automotive engineers that are used to building internal combustion engine powered vehicles, having to take on all of these other technologies in order to make a vehicle like that has really been something that's pushed them. And I think where we've seen this multidisciplinary need really become very prominent more recently, and the tools we create, as you said, Brian, give us sort of a perch to see that coming together when you combine these different technologies together.
Anybody else want to weigh in on that?
I think another aspect is that innovation has become much more a part of a development process. You used to have the basic research labs that would create technologies, not necessarily connected to a specific product or a deliverable. And what's happened among our customers is that there's been much more of a connection between what happens in the research labs and what happens in the product development cycles. And there's also much more of a borrowing and adaptation of innovations from one field into another field. A little bit of what Paul was talking about in terms of that multidisciplinary, multi-domain convergence. There's much more borrowing and integration and reuse to create innovation in a certain field. So I think that's another thing that's going on.
I want to follow up on that before we get too far afield, because you mentioned R&D research labs at a higher level. I mean, we've lost a lot of the basic R&D that we used to do through Bell Labs and places like that. Funding is always a challenge through NSF or other government agencies. Is that a problem, or are we figuring it out at another level?
Well, I think one of certainly the central research labs, the Bell Labs, played an important role. But at the same time, a lot of what was created in those labs wasn't utilized, wasn't monetized, right? Because it was technology in search of an application. And what's going on now, we see in a lot of places, is an engagement model between people who want to build a product or a system or whatever it happens to be, dealing with researchers at an appropriate level of engagement and arm's length. Because you need independence to create innovation. If all you want to do is build product X and fit into a box, there's not a lot of innovative scope there. And so when I talk about development processes, a lot of it is engaging a research community and a development community at the right level of interaction. So yeah, the picture's changed, but I think it's creating opportunities too, because a lot of the research activities are being driven in very practical ways and being reused in very practical ways.
That's good to hear.
Another element of that is the vehicle of communication between the researchers and the product developers. And through that direction and better ways of communicating either requirements from the market or constraints on a design, the researchers are now better equipped to produce proofs of concept that actually that people are making decisions, either engineering program managers or the people who are running the business, to gauge the economic value of an innovation. And that was much more difficult in the past, but the fact that they can now have the tools to create functioning prototypes and take it out and actually test it. And we see this happening in, the Volt was an example, but you see this happening from everything from, hearing aids to spacecraft. And so the range is really astounding, the ability to use software and tools to be able to get those prototypes done more quickly, where you can really evaluate trade-offs and say, is this going to be economic and viable in the market? And that was very difficult to do 15 years ago.
Oh, yeah.
The build on that whole, all the things we're talking about, the convergence, the collaboration, and things like that, right? One thing that you do see is, earlier you might have had the park or something like that. You see a collaboration now across kind of the global supply chain, if you would, right? Across companies, not just in one location, but across multiple locations as well, right? Just as there's collaboration between research and development, there's collaboration between different companies to get innovative products to market faster, right? And we see that quite a bit as well.
And you could take the Strawberry Vault example, which is a convergence of different technologies. I think, building on what Samir said, there's also a distribution of problem. I mean, in other words, if all you had was a certain scope product you need to build, fine, well and good. But now every product is connected to another product, connected to another system, connected to another system, and the behavior and the design challenge is a connected one, is a coupled one, right? So if you take the Vault, it's got to have a source of electricity. People are then saying, how do you take a hybrid or an electric vehicle and make it a generator, or a battery, not simply a consumer of electricity? Right. So then you've got to figure out how to pay it back into the grid. Then you've got to figure out how to do it cleanly. How do you come up with pricing models for doing it? And all of a sudden, the transportation vehicle becomes part of this connected thing that gets into grid, clean power, energy trading, et cetera, et cetera, et cetera. And so the scope of the connected problem is bigger, which is good because that drives a lot of research.
In our business, you couldn't have predicted 15 years ago that how we would engage with readers would be what it is today, which is almost, we're still an information source, but we're also a community, or we try to be a community. And you couldn't have predicted that 10 years ago, if you asked either of us, I'm sure. Do you have any sense, given that completely unfair setup, for how your customer base will be designing and innovating in 15 years?
From now?
Yeah.
Well, okay, there's a piece of me that says, let's look back 15 years in terms of what our customers are doing, and even 20, 25 years. They were, whether it was in research or in product development, they were coming with ideas. Those ideas were captured in tools, MATLAB being a very good example, and they were sharing them with other people to say, here's something I came up with, here's my innovation, try it in what you're doing, right? Apply it. Learn from it and apply it to what you're doing. If you have a better approach or could build on it, do it to it and send it back to me, right? So even in the early days of Mathworks, it was a very collaborative, dare I say, social computing type of interaction between our users and the entire community, and that was great. And in a way that has evolved, you no longer use FTP sites, you use portals, communication centers, collaboration centers, and things like that. But in a way, I think it's an updating of the same thing, which is I've got a cool idea. How do I make it? How do I express it in a way that somebody else could learn, understand, apply, elaborate, build on, integrate, design, right? So it's similar, but the medium is different, clearly.
And I think we'll just continue to see that happening over time. The same need for collaboration is there, but the tooling will get better and better so that people can do it more efficiently over a wider scale and in a more natural way. So it's not about here's my work and here's my collaboration, but now it's all together in one workspace, some of which is collaborative, some of which is my own. So I think we'll probably see a continued progression in that direction.
Right. One way that's happened is the progression from kind of static representation of requirements to something that you can actually build a model of and simulate it. And that's really come a long way in the last decade, but you could imagine that going even much further, where you could just, the customer could provide some kind of virtual representation of the target application or the environment in which some innovation is going to plug in, and provide that to a vendor and say, this is where your device is going to be operating, make it work and make it better, faster, cheaper, or whatever the innovation happens to be. And those models of that target environment or the application can really inform the innovation and allow the innovators to do much more effective and faster trade-off studies and understanding of they're building something that the customer really needs because they can test it long before it's ever built.
So if I extrapolate a little bit, we'll see this greater leveraging of the cloud, presumably, and social networking concepts, not necessarily the platforms, or maybe the platforms, to drive more collaborative research, more collaborative design. Do you guys internally use any of those tools now as you're building software?
We try to build a lot of adjacency physically, so we co-locate teams. There's a large piece of that. We use tools, systems, I'll say web-based systems, to share specs, share ideas. And we use a whole bunch of different approaches in terms of how we come up with ideas, ranging from telephone, email, to other stuff. So a lot of different media.
Yeah, I think it's really the combination of all those things together that, and every company probably comes up with their own balance of how much of one versus the other. But it's a constantly evolving landscape. So, we try to stay on it, the forefront of it as much as anybody.
So I think when you talked about 15 years from now, I think that we approach it two lenses. One of them was, I'll say, the pure, a research-oriented approach, sharing ideas, sharing techniques, methods. And I think what Ken discussed is a very important other aspect of innovation, which is if I'm working in a supplier network, right, I need to integrate a bunch of stuff, and I need to work with a bunch of other people who are going to be providing potential components to it. How do I and my partners innovate in exploring a design space and coming up with the right approach, which is an innovation by itself? It's not a pure new concept, but it's an innovative way of putting stuff together to do what I want, right? And that's almost a process innovation in a way, which is just as important.
How do we strike a balance? I'm keying off something you said earlier. We're keenly, as an engineering innovative culture, we're all keenly interested in monetizing an idea as quickly as possible, right? We're getting much more efficient, much more productive going forward. But how do we strike a balance between what we used to have, which is research labs in places where there was no pressure to do that? Mm-hmm. You just had to come up with some ideas, sometimes for ideas' sake, and that was okay. And then maybe somebody eventually would come in and figure out, I could do something with that.
Yeah.
How do we strike that balance, or do we have to?
I think you have to. I mean, I think that if you look at a lot of companies that we work with who use our tools, they have almost concentric circles of R&D teams, right? Some that are that have closer adjacency to the product teams, if you will, the people who are directly responsible for monetization. And then there are the people who are further from the product teams and closer to that kind of a basic R&D function. But there's the key thing is that there's communication between them, right? I don't have if I'm in a pure R&D, pure research function, I may have multiple constituents who will give me interesting problems that will help me drive my research, but I don't directly have to monetize it. And then you go circle outside that, and there are people who say, I can give this, I've got a basic research team that I can give interesting problems to, but I know how to monetize it. So I think you see much more a model of connected R&D functions. And in some cases, they section their research groups very specifically that way, to say these people will be directly responsible for how this stuff goes into products. Other people are further from that process and are more in a basic research function. Yeah. But they all live in the same organization.
Right.
Are there ways that your tools have changed over time that maybe you didn't anticipate, or are there ways that you think they're going to change over time in the way people interact with them and the type of people that interact with them?
Well, there are a number of, I think certainly yes. I think we've become much more conscious of different styles of use of the product, where someone might be a casual user who needs to solve a problem every once in a while, whether it's analyzing data or they might actually be a consumer of a tool that was developed by an in-house expert, and then they're just using a packaged application using our tool. So we're facilitating that by allowing the experts to deploy something that is really focused on a specific problem that customer or end user needs. But even just the raw use of our product, we're more clearly distinguishing between the people who are those casual users versus the more power users who have a deeper domain expertise or the ability to program or use advanced modeling tools. So I think as our products evolve, we're getting, you see capabilities coming out that are more clearly targeted to one class of user or another. It's very difficult to just have one offering that satisfies everyone, but and we do have both very clearly. So we need to be, really focusing the efforts to satisfy both types of constituency.
The way the user interacts with the tool or with the computations or the simulations or whatever will always be in the context of the way they think of the problem, right? So, for example, people in the finance community often want to view their problem through an Excel lens, right? So it was very important for us to be able to provide MATLAB with the ability to plug into Excel. So it's a very natural front end to a very powerful back end, as well as the ability for someone just to create a custom graphical user interface in MATLAB, because there may be a very custom way of looking at the problem that's specific to an area, whether regardless of engineering, science, or whatever area. And so people need the ability to write a user interface, or to build a user interface just in MATLAB so that somebody can just point and click their way to a solution.
We have something called as MATLAB Central, where people can share the utilities they have developed, with models that they have developed with each other. They just put it out there, and you can reuse somebody else's work to speed up your own innovation. Right? So we had this social community thing called MATLAB Central way before social community became cool as it is now. Right?
And to your point of the interaction, actually both your points, we baked the link to that MATLAB Central into the product. So from within MATLAB you can say, let me look into this repository of what people have contributed. And so it becomes a seamless experience.
Yeah.
Right?
Yeah.
Because that's what you want, right? Have somebody else face the same problem and have they solved it. If they have, good for me, right? I can build on that and I can take it one level further.
Right. And I think that's really the salient attribute of open source that drives its appeal, is that somebody has already solved a problem and you can build on it. And that we have that element in our community site and building that into the MATLAB environment.
I've noticed, that there's a big push right now to get kids more into engineering and into technology fields. And I know your product has been used in tools for students. Are there things coming out, or is there places you see it going, or you see education changing, maybe even technology schools, that ways they're using your tools, or ways that they might be introducing science into the classroom in middle school, high school, even undergrad, that are new, that you see happening?
There's a number of these now that are pretty inexpensive development boards, processors, with peripherals for doing cameras or controlling small motors, that are great platforms for people to learn engineering and to learn about targeting and running systems in real time and getting real things to work. And so we've worked to make our tools be able to communicate with those devices, be able to deploy code onto those devices so that students can learn and test on very, very inexpensive hardware that just a few years ago would have been price prohibitive for them to get a hold of that kind of hardware.
I think Jim used the phrase earlier, learn and apply, right? All these, be the Lego or the Mindstorm or whatever you learn, you can apply it right there in that class and build something and actually see it move, and allows you to put all of that classroom learning into the context, right? That's really useful for them when they go get a job, right? Because right from day one, they're productive in their jobs. Right? And there isn't that big ramp up involved for them to be productive as engineers or scientists. And that's a big change that we see.
I think in engineering education, whether you're starting freshman year or whatever, the traditional engineering curriculum was front-loaded with the theory, right? Because the pedagogy said you must understand the concepts before you can apply the tools and the techniques. And I think over the last dozen years, there's been a resorting of that approach, which is engage, almost demonstrate the end result of the learning,
Right.
and then build the foundation, the conceptual and theoretical foundation in supported by tools. And supported by simulations and supported by that. So it becomes much more of an experiential learning process as opposed to a prerequisite-based learning
Right.
process, right?